Welcome to Tech Hub. I'm Steven.
AP.
And I'm Travis.
Welcome to the Hub, man.
Thanks.
Well,
it's nice.
For this week.
Yeah, this week. I'll be back in, 2 weeks?
Yeah.
2 or 3 weeks.
When you moving in full time, man?
Yeah. When are you coming out here, dude?
I'm not, but I love visiting. It's a great place to visit, but, family, we're in Salt Lake, we'll stay there.
Of course.
Didn't you guys get a lot of snow there?
We get a lot of snow, but you get a lot of snow.
Yeah, that's
Not
true.
so much.
You guys already got some this year, didn't you?
We did get some last weekend.
I thought so.
No
I
way.
thought I saw that. Yep.
Wow.
Small
Winter
world.
is coming.
It is.
Winter is
Just
coming.
give me some fall, please. Some fall, and then maybe get through
Right.
Halloween, and then you can have snow.
You don't
I
want to
agree.
go trick-or-treating in your snowshoes?
I don't think my daughter wants to go trick-or-treating in her snowshoes. But she might
Doesn't
do it
sound
anyway.
fun for anybody.
So we're going to shake some things up here today, AP. Travis and I were chatting, and there's a pretty big product for the manufacturing group that
Right.
also ends in a 360.
Shocker.
Who knew?
Ironic, right? Right? There's something consistent about our product naming.
Exactly.
Well,
figure.
our videos, we've mostly construction platform centric, but
Yeah.
I want to move over to Fusion.
Sweet.
And still can't truly understand. Why don't you tell me, if you can, what is Fusion 360?
Fusion 360. It's a lot of things. We talk about it being our product innovation platform. What does that mean? Those are some fancy
I have no
words.
idea what
Right,
that is. You might
right.
want to dumb it down a little
So
bit.
we'll dumb it down a little bit. So you think about the different aspects of manufacturing. You think about the make, you think about the use, and you think about the design. Well, Fusion, what we want it to be is that one platform that encompasses all of that. So not only just from designing, from simulating, testing, but also for manufacturing purposes, right? So if you're doing 3D printing, you're doing additive manufacturing, or you're doing traditional kind of subtractive manufacturing. But then like how your customers interact with it as well. So think of like the Internet of Things and how all that plays in. And then, it's just really, we're really focusing on bringing everything that we have to offer inside of Fusion.
Have you given that
Very
spiel
good.
before?
A couple times.
It's pretty good. It's pretty good.
That's pretty awesome. So 3D parametric modeler for the manufacturing?
For sure. 3D parametric modeling. We also introduce a couple different things inside of Fusion where you look at like T-Splines modeling, which is a nice NURBS-based, really complex surface modeling if you need to accomplish that and not have to worry about like old archaic systems that are really powerful, but it's hard for new people to learn.
Yeah.
So with T-Splines, it really helps them get those concepts out, get them out a lot faster, but still have that true power of like, hey, if I need to switch over to parametrics, I can. But also throw in direct modeling. So Fusion does all three: direct modeling, parametric modeling, and freeform modeling, all inside of one package. And that's just one sliver of what Fusion can do.
So what does that even look like? Because does the interface, so I guess to take a step back, it sounds an awful lot like Inventor.
Yeah, it is. It's a lot like Inventor, but it's a whole new platform.
Okay.
Right. So Inventor's got some great technology. I love Inventor. I've worked with Inventor for the last 5 years, but we saw a need for like the changing platform and trying to take full advantage of cloud computing and all that technology. So having a platform shift, that's really what Fusion was derived for. And so now connecting all these things, because
Very cool.
you talk about like Inventor, you talk about simulation, you talk about CAM. We can do all those things, but typically we got to add something to Inventor, or we're just doing it all in Fusion.
Sure.
Very cool.
So is this kind of like our other 360 products where primarily cloud-based, interactive?
Yeah,
Is
so
it-
there's a desktop client, right? It still installs on your
Okay.
desktop, but we still take advantage of like the cloud for when it makes the most sense. Data storage,
Right.
right?
Yep.
Who needs to build their own server farms when we have the server farm we can leverage and host all that information there?
Sure.
Rendering, right? Run rendering on the cloud. They're even in the product roadmap, right? And that's the other thing I love about Fusion is just how upfront we are about like what's coming in the product. Before you have to worry about NDAs and all those things, you don't have to with Fusion. It's all up front. And so simulation in the cloud, something that's coming up real quick.
That's cool.
Great.
That's cool.
Great.
FEA, simulation would be finite element analysis, right?
Yep, you got it.
That's some of the coolest stuff that our products don't, maybe like robot structural, but that's still going on the design side. That
Sure.
we don't get a ton into that because we're more of, we know the structures and strengths of materials.
Right.
But when you look at additive manufacturing, subtractive manufacturing, you're using metals and composites and components that
Sure.
might not be listed in the AISC manual for steel construction.
Sure.
Right. Yeah, and we have a labs group that dedicates that and doing material testing and things like that, so we know we can get accurate stuff.
That's
Great.
awesome. That's awesome.
Great.
So what can you do in Fusion? What can you show us?
Well, I can show you a couple of different things in the different environments. Also, I think I got some different kind of unique cases that we can talk about Fusion as well. I know you
can't
chuckle.
wait to get to this.
I know you chuckle. You talk about buildings and those things. I
Yeah.
can do buildings too.
I've seen this one
different
before.
skill
I like
set.
this. Like where we're heading.
Yeah. So let me show you a couple different things in Fusion. Here's our platform. We talk about Centric is Fusion 360. There's a couple other things that build upon that. But when we're in here, we talked about a couple of different spaces. We talked about modeling. We talked about CAM. We talked about CAE. We talked about simulation. All those are essentially just environments that we enable inside of Fusion. You get it all, but it's just a matter of different spaces. So here I'm in the modeling. You can kind of see. I can also go out rendering. I've got animations. So if I need to build like assembly documentation or exploded views, I can do that. If I need to do that finite element analysis, well, we got an environment for that. And also we've got CAM. And the big benefit is it's all integrated. So I mean, there's CAM products and there's CAD products, but traditionally, how do they talk together?
Right.
So if you make a change, well, then you got to re-export, re-import, redefine all your things. Not the case with Fusion because it's all integrated. So let me show you a couple
conversation
things.
a few times.
Yeah, definitely.
Yeah.
Integration.
You don't want to have to sit there and your model, your prototype is going to go through a lot of iterations.
Right.
Same thing with a design model.
Absolutely.
I don't want to go through and change all those detailed drawings every single time or have to rebuild my environment for my testing or whatever it would be.
Yeah, same concept. I mean, your detailed drawings, like you're pulling off your structural detailing, right? You got automated widgets to kind of create those, but you don't want to have to change that every time and redo that.
Mm-hmm.
Same concept, like your end deliverable is different, right? I got to deliver a part that's going to be machined so I need some G code. So I mean, I want that to be able to get that as fast as I can, and not have to wait till the end of the product to then be able to generate that. Let's just do it at the same time as we go.
Awesome.
Great.
Awesome.
So, couple quick things I'll show you here, and then we'll get into some of those use cases. What I'm going to show you here is some T-splines modeling. It's some really cool stuff. You can kind of see here, we get in this different environment, so we can really start to work upon that. But what I want to do is actually kind of show you where that might seem a little bit fit differently. So here we kind of see the entire product that we're working with. This is our Ember printer, one of I typically use just to kind of highlight a lot of these different functionalities. But here, how it's all set up, right? I got my assemblies, I got my parts, my sub-assemblies. I want to take a look at that top cabinet because what I want to look at here is creating that T-splines body, which really, like I talked about, is how do we create surface geometry quickly and be able to iterate fastly. So here we can just simply build this out. You can do it traditionally. I could build like a circle and extrude it. But what Fusion allows us to do is to take that and add some complexity. So if I want to do something like symmetry, I want to take this guy and I wanted to kind of really drastically kind of change that. Just pushing, pulling, manipulating, I can create some awesome surfaces without having to worry about like traditionally how you do that. Traditionally, I would maybe say, hey, here's a sketch and here's another sketch and another sketch, and how am I going to combine those together?
Sure.
And something else, it's like traditionally, right? So let's grab this guy and let's add some additional details to it. So if I wanted to maybe add like another insertion point here. So I'm going to grab this guy and I'm just going to simply just add some more detail. So I want more control. That's what Fusion can do for you to quickly get some of those ideas.
Great.
So in this example, right, I know it's not quite scaled correctly here, but what if I wanted to add some grips, right? Just pushing and pulling. And T-splines, how it handles it a lot differently. See where this comes together? That's why they call it T-splines, because it's a T-joint. Mind-blowing, right?
Wow.
One of the only technologies those that can do that, because traditionally what you have to do is add all that level of detail throughout the entire surface you're working with. So you're adding a lot more complexity. So if I tweak something, well, then you got to worry about like how things are transitioning, but T-splines helps you out with that.
Awesome.
Great.
Awesome. So T-splines, I want to take a step back to that because NURB surfaces, they've been in AutoCAD for many years, but you can't do T-splines. And that NURB surface, you'd never be able to get that kind of accuracy and that kind of symmetry using just the 3D modeling tools in AutoCAD.
Yeah, I mean, there's other tools like Alias. Alias is NURBS-based and super powerful, but you've got to have a specific skill set to use that, where something like T-splines inside of Fusion makes it a lot easier.
This seems pretty intuitive too. That's one thing that jumps out at me. Obviously a lot of power packed in there, but it seems pretty intuitive, the tool sets available to you.
Yeah, I mean, you think about it. I mean, we try to keep everything consistent based upon whatever you're doing. So, I mean, trying to help that intuitiveness of it to really start adopting, because it is, it's subscription based, right? We want to drive adoption because that's how we keep people coming back.
Definitely.
Drive adoption. I like that. That's a good brand to have. It's a good term. So talking about driving adoption, who's using this?
A lot of people are using it. I mean, we had a lot of different customers, and I think we talked about Inventor a little bit at the beginning, but really what it's done for us is open up another environment, another place we can go, like industrial designers, right? A big bunch of people we can go out there to kind of get that different types of people we can start to work with. I know we just closed some other deals and some things. I don't know if we can necessarily talk about them. We're just closing today, but I mean, different consumer products, right? People who make, cameras and devices, things like that, electronics.
Oh, cool. Sure.
If there's an aesthetic piece to it, that's really what T-Splines can help with. But also because there's the CAM environment in there. So I've been talking to a lot of machine shops lately. So talk about disparate systems, right? That whole thing we talked about with, I got my CAD model, got my CAM model, and right. So really helping them solve a lot of those different workspaces as well.
Great. So what are some of the use cases that you can do with this?
Yeah, so quickly let me show you in here. We got this, we got simulation, right? So we wanted to show you just kind of some results inside of here. And one of the coolest things I think is about it is how we can just look at some of the results, right? So you're like, hey, factor of safety. Is this thing going to fail? Well, whatever load I supplied, well, it's 3+. It's going to be able to sustain that. But if I wanted to, I could dive down in right into those specific areas where I might have some problems with stress concentration.
Sure.
Other things we can look at, right? So we talked about some machining. Well, let's go ahead and we can generate that and kind of give you a preview of what that looks like, right? So being able to actually see what your cutting path is, so actually running the G code, and then being able to post this out, right? So that's another great thing that comes with our tools, right? The post library, to be able to actually get the G code you're going to need to run on your Haas machine.
That is very, very slick.
Awesome.
Right. So there's some of the different environments we want to talk about. You said use cases.
Yeah.
Right.
Yeah.
So let's. I got a couple queued up. Let's pull up a couple different things. We're gonna start here. One opportunity I had is this helps talk about some of the different things because it's a platform. So also being able to take that and expanding it out to our partners, right? So giving people writing in code, right? Writing in applications. In this particular instance, we're talking about like apparel, right? Creating a backpack, right? You can kind of see some of the T-Splines in action. But with a backpack, it's soft goods, right?
Yeah.
So it's not traditional. I'm going to cut it. I got to have a flat pattern, and that cloth is going to stretch. Well, we have add-ins like Exact Flat that can actually calculate those types of things, right? So as you can kind of see, I get kind of a final idea or a concept I want to run with it. Well, now how am I going to actually manufacture that? So Fusion being a platform, reaching out to our partners, giving them opportunities to be able to write, add-ins for that and those types of things. And Exact Flat just happens to be one of them, specifically for apparel.
That's awesome.
That is pretty awesome because I mean, I've seen with just stainless steel and make a plate, and you got a fold in the plate or a curve in the plate, and what is that true length? Well, it's very difficult to hand calculate, and some of our software can show that. But for fabric, that's I never would think that you'd be able to just use Fusion for a backpack and be able to get what that would look like and prototype it.
Yeah, and another benefit, right? Be able to get there quickly. Because there's other ways you go about it traditionally, but how do I get there quickly? And Fusion helps us do that.
Yeah, I think that's one of the coolest aspects for our end. So different in the AEC side, right? We have those static materials we always are dealing with.
Yep.
This opens up a whole new world of possibilities to input. So.
Brick, mortar, steel.
Yeah, right.
But glass,
don't get too crazy.
wood.
Yeah.
Then I know I've shared with this. I mean, I bought a bus recently.
I think this is the greatest thing.
Right? Yes, this is awesome.
I won't steal the thunder. You got to tell a story.
So I love the Utes. I love tailgating.
Who are the Utes? Is it kind of like two Utes?
Two Utes.
Two Utes.
You know who the Utes are, Steve.
Nah.
University of Utah, college football.
I come from a region where college football is probably not the biggest thing that we have.
College football, University of Utah. We go by the Utes.
Named
after an Indian tribe in the Utah Valley. Okay.
Hey,
Go
thanks.
Utes.
Thanks. Thanks for the eloquent
the dumbed down
explanation.
version.
Yeah, thanks.
So
You got
right
it.
now you are building out your dream
I am.
Your dream.
I'm building my dream inside of Fusion.
Yeah.
Let me show you
You need
something
to see
really
this
quickly.
because it's going to be your dream coming up.
Oh,
real
I've
soon.
seen this. It is awesome.
Okay, so we talked about rendering, right? I wanted to create some renderings, and what better place? I live in Salt Lake City. Let's throw it on the Salt Flats. Right? So you
Right.
can bring in those images right inside of there. But the thing I was trying to do is trying to communicate with my team. In this instance, my team was my wife, right? So I wanted to communicate to her what we have access into here, right? So it's not just going to be a tailgater, but it's also going to be an RV. So I want to be multiple disciplines, but when I'm out there tailgating, I want access out my back door, right? So I was trying to show her that, and with Infusion, I can enable some of those motions and those things. And better than just me showing her on the screen, we can actually create nice, high-quality renderings that we can actually do that. So we have the full animation, publish it out to a nice little rendering, and then I can really communicate with my team, what's going on. So yes, not everybody builds buses, right? But some of those same aspects. So how do I communicate those design ideas?
Totally.
I mean, that's really what Fusion can help you do to really elaborate on that.
I mean, that's
Absolutely, man.
that's just absolutely gorgeous. And again, it's the same. It's that same concept, and a lot of people have been talking about in the industry how manufacturing, architecture in AEC is becoming more like manufacturing in the way.
Yeah.
that
Oh, yeah.
how much easier it is to convey a 3D model to somebody, a 3D rendering, than it is a 2D set of plans.
Totally.
Not everybody can comprehend and be able to get that 3D visual mindset
Totally.
of
Yeah.
a 2D set.
Same thing, same concept. You talk about architecture, right? Homes, right? We all got homes, right? We all want to do modifications to our homes, right? So again, this is just showing you that, Fusion, yes, we have a specific use case. Yes, there are things, but just showing you kind of what we can do.
Right. Broader
Same
possibility.
thing. I wanted remodeling my kitchen, right? We're removing walls, and I wanted to show my wife and
You
kind
have
of get
to
sign up
convey
on
it
it.
to the team.
Right. Again, conveying that information to the team. Well, I can create these nice walkthroughs of my product, not even just from inside of Fusion, but even through like a web browser, right?
Right.
So Fusion, we have a mobile app, right? You can actually do walkthroughs and fly-throughs. One question my wife had is like she had watched a lot of these fixer-upper shows, and she loved this idea of shiplap, right? So here's an actual picture of what it turned out like. So I'm just kind of showing her, here's the digital model, here's kind of the after model, and just showing kind of communicating that information.
Is that a rendering?
No, so that last one was actually with the actual finished product. Right? So I actually did
Great job.
build my kitchen. So
That's
thanks.
beautiful. Awesome.
But again, communicating to the team, how are you going to do it? You're going to do it via like a live sharing session, right? We can do that. Or you want to create some renderings. We can create great renderings, or even just design reviews and markups. We do all that
Right.
inside of Fusion.
That's pretty awesome for cross collaboration. I mean, your designers might not be in the shop. They
A lot of
could
time
be
they're not.
Another office, another
Sure.
facility, another state.
Some of the best ideas you probably get are when you're at home,
Sure.
right?
I would think so.
Yeah. So,
So here's one thing.
yeah.
'Cause- So I actually used to support AutoCAD Mechanical, and it 2D, really awesome program. You can create all your third angle projections, which is your top, side, front, and then the ISO view. A lot of companies still have those sitting around, and they're still building off of those third angle projection plans. How do they get into this environment?
So yeah, great point. I actually have another video. I can actually bring that up as we talk about it. So going from 2D to 3D, there's still a ton of customers that just have
for sure.
AutoCAD. They haven't moved to 3D. They maybe want to get there, but want to make it easier. But that's a lot of legacy data. You don't want to lose it.
Ton.
So we can actually reference that inside of Fusion. And what's super cool is, like you said, those 3D projections, the top, the side, the front, we can use all those, and we can create what I call a pseudo-isometric view. Then we could then use kind of just regular techniques inside of Fusion, creating 3D models from those views. And then at the end of the day, what happens if it changes? Well, we can build parametrics into it. So then once we build parametrics into it, we can create a new drawing that anytime we make those changes, everything's going to update. End of the day, we still end up at the same results because those 2D drawings are what's needed for manufacturing.
Yeah.
But now we have the 3D model representation because, hey, what if we have to cut this out on a CNC machine?
Sure.
Good luck doing that off of 2D drawings.
Oh, absolutely. Because you're not going to get the G code out of that.
Exactly.
Man, so nice not to be able to have to throw it all away, right?
Yeah.
Recreate the wheel.
Well,
Yeah,
I
it's
think
all
that's
that
very
data.
important. And we
Yep.
talk about driving adoption. That's how you drive adoption. You don't ignore the legacy.
Well, it's a big hurdle, right? I mean, we've heard that plenty of times. AutoCAD to Revit, I'm sure the same
Yeah.
thing here. It's you have a built-up library, you have a lot of legacy data. You don't want to just throw it all out the door. So
Yeah.
That's awesome.
Wouldn't make sense.
Yeah. Sometimes I really enjoy when things make sense. Well, hey, Travis, thanks for coming by. Thanks for being
welcome.
part of this.
Yeah, man.
And I'm sure we'll dive a little deeper
Yeah,
in
let's
the
dive
future.
deeper in the future.
Absolutely, because there seems like to be a lot in Fusion.
Absolutely.
I still can't believe that you modeled your house.
So cool, man.
That it's
I don't have the Revit skills like you do, Steven. So I had to make do with what I had. Fusion's what I had,
Oh,
and
that-
it turned
that's
out
the
pretty
Revit
good.
skill
When
guy.
you driving the bus out here, man, gotta get a tailgate.
I'm trying
in
to
there.
think when we get the next time we get Colorado. I think we're here this year. Bus isn't quite ready, so maybe in
Right.
2 years we'll drive it out when we play those Buffaloes up in Boulder.
Done
Can't
deal,
wait,
man.
Can't wait. Well, thanks for coming by. Thanks for watching. As always, questions, comments, concerns, please subscribe. And suggestions, we're always happy to take them. And we'll see you next time.
Thanks a lot, guys.
Thanks for having me.
All right, take it easy. Bye.